Okay, we're going to solve more equations today, and we're going to use something called the distributive property. Put it in different colors. Distributive property. That is what we're going to be talking about today. Alright, before I introduce it to you, I have a question for you. It is, what would be the answer to this question right here? I know I have it written twice. Just look at the first one here, the one I'll highlight. How would you get the answer to that? Well, if you remember bed mass, what we always said to do with bed mass is the brackets first. So in the brackets I have 3 plus 1, which is 4. I'll keep that in brackets. And I have the 5 out front. What does that mean? When you have a 5 and a 4 side by side with nothing in between, it means multiply. So 5 times 4 is 20. Okay, fair enough. But I want to show you something. There's another way you could actually get this answer 20. I'll give you a hint. You see what to do? If you multiply, remember how we multiplied 5 times 4 here? You get 20. Well, you could also get this answer by going 5 times 3, which is 15, plus 5 times 1, which is 5. Add those together, you get 20. That's the distributive property. Now, you might say, well, what the heck? Why would we ever do that? I mean, we already know. Just add the bracket, then multiply, we're done. Why would you do that? Because sometimes, like if you look down here, you can't add the stuff in the bracket. Look at this, y minus 2. I can't do y minus 2. Well, how come? Because I don't know what y is. But you could still do the distributive property. So this is going to help us solve equations. It's going to help us simplify polynomials. It's a pretty useful and powerful thing, the distributive property. So the way it works, as you saw here, is I took the term out front, in this case it's 5, and I multiplied it by both terms inside. Now, if you had a bracket that had more than 2 terms, you'd multiply it by all 3 terms or all 4 terms or whatever. But that's the idea. Take the term out front, multiply by everything inside the bracket. If you want to see what it looks like mathematically, here it is. A times B plus C is equal to AB. That means A times B. And why is it equal to that? Because you're doing A times B plus A times C, because you're multiplying those as well. Now, distributive property is the real name for this. You can also say when you do this, when you multiply it through, you can say you're expanding. So expand is when you use the distributive property. And then I also have some cheesy names for it. I used to always call it mountains, because look, when I do these multiplication things, you see the beautiful mountains that show up here. You could draw a nice sun in between them if you want. Maybe some birds flying overhead, whatever you want. So I used to call it mountains all the time. But then a student teacher of mine a little while ago, he came in dressed up like a farmer when he was teaching this. I was like, what the heck? And the reason he dressed up like a farmer is because he introduced the idea of that the farmer outside here in the A position is feeding the chickens inside. He's throwing the grain inside the fence. The fence is the brackets, right? So he's throwing grain to B and he's throwing grain to C. He's feeding the chickens. So expand is the real name. I sometimes call it mountains. And you could also call it feed the chickens, which seems to be becoming more popular as the years go on. Why wouldn't it? I mean, feed the chickens is pretty awesome. So let's try this. Now, these aren't equations. There's no equal signs here. These are just some expressions. And we're going to simplify them by using the distributive property. So if you tried to do something in the bracket here, there's nothing to do. You can't do anything. But you could simplify this by expanding, using the distributive property, the mountains, feeding the chickens. So first of all, we multiply 3 times 5x. Do you know how to do that? You just multiply the 3 and the 5, which is 15, keep the x. So 3 times 5x is 15x. Then you multiply, notice I'm not putting the negative down yet, because what I'm going to multiply is 3 times negative 2. I know that's a takeaway 2, but again, you got to get used to thinking of it as takeaway, but also negative. So this is 3 times negative 2, and 3 times negative 2 is negative 6. There's your answer right there. Okay, so again here we multiply 6 by y and also 6 by negative 2. 6 times y, don't think about it too much, it's just 6y. If you're wondering why, because there's an invisible 1 in front of that y, and 6 times 1 is still 6. Then you're going to go 6 times negative 2. Notice I haven't put the sign down yet. 6 times negative 2 is negative 12. So because it's negative 12, I put minus 12. Right? The negatives, the minuses, it goes back and forth. Sometimes gives people trouble. And then after you've done it for a little while, it just becomes second nature. Okay, here's another one. We're doing 5 times negative 2 and 5 times 3m. We're feeding the chickens. 5 times negative 2. Well, that's only one negative, and 5 times 2 is 10. I don't write down a sign yet, because then I'm doing 5 times positive. I know it's a plus, but it can also be a positive. 5 times positive 3m. Well, there's no negative, so it's positive. And 5 times 3m is 15m. Multiply the numbers together and keep the letter the same. Okay, getting pretty repetitive here, isn't it? But now we're getting some negatives, so it gets a little bit harder. We're multiplying negative 2 times 4n. So you go negative 2 times 4, which is negative 8, and slap on that n there. Don't put down the sign. Definitely don't put a plus here, because look, we're going negative 2 times positive 2, and a negative times a positive is a negative. 2 times 2 is 4. So we get negative 8n minus 4. Alright, what's different about the next one? The difference is you need to feed more chickens. You need more mountains. You got to multiply first term, second term, third term. So 2 times 3x. We go 2 times 3 is 6 and slap on the x. 2 times negative y. So again, there's an invisible 1 here, remember. So it's like 2 times negative 1, which is negative 2, and slap on the y. And then 2 times negative 4z. So 2 times negative 4 is negative 8, slap on the z. There's our answer. Last one, what if it just has a negative out front? What do we do here? Like, can I do this? Yeah, you can. If it helps, imagine again, what number is right in front of here, even though you don't see it? It's a negative 1. So really what you're doing is negative 1 times 5m. Well, negative 1 times 5 is negative 5. Keep the m. Don't put down the sign, because now we're going negative 1 times negative 2y. Negative 1 times negative 2 is positive 2, and keep the y. What you'll notice is when you have that negative in front, it just changes the signs of everything. This was a positive 5m and minus 2y. Now it's become negative 5m and plus 2y. But another way to think of it is distribute that negative 1 to both of them. Alright, so now we're going to use the distributive property in equations. So here's our steps, including the distributive property. The first thing you're going to do is get rid of the brackets by using the distributive property. If you look at the equations on the back of the page, you'll see they're equations, they have equal signs, and they all have brackets in them. We want to get rid of those brackets, and the way we do it is by expanding, by using them out, by feeding the chickens, by using the distributive property. Okay, the second step, which we've already talked about, is we're going to isolate the variable. How do we do that? We do some adding or subtracting, some multiplying or dividing, right? Opposite operations. And remember, we're always going to add or subtract before we multiply or divide. The third step is an optional step. You can check your answer if you want by plugging back into the original question. So let's go. Here's our first question. 4 times w minus 2 equals negative 8. So the first thing we want to do is we want to get rid of those brackets. So we're going to expand. We're going to feed the chickens. 4 times w, remember there's a 1 there, so 4 times 1 is 4w. And 4 times negative 2 is negative 8. And it still equals negative 8. Hey, now we're back down to a two-step question. We need to isolate this w. We got to get rid of the 4 and the negative 8. Which one would require adding or subtracting? Because remember, we've got to add or subtract first. The negative 8 or the minus 8, we're going to get rid of that by adding 8. What we do to one side, we also do to the other. So those 8's are gone, and we have 4w. On the other side, negative 8 plus 8. Wait a minute, those all cancel out. You're left with nothing on this side either. What do I do? Well, you got to put something here. If those canceled out, or what does this equal, negative 8 plus 8? It equals 0. Don't panic. It still works. Just keep following the same rules. We have 4 times w. We want to get rid of that 4, so we have to do the opposite of multiplication. We need to divide by 4. What you do to one side, you must do to the other. So those cancel. You're left with w over here. 0 divided by 4. 0 divided by anything is 0. So w equals 0. Ooh, I don't feel confident because 0 is kind of a scary answer. That's okay. Plug it in here. Let's see. Start with the brackets. Right? You don't have to do the distributive property. If we have an answer, let's go back to doing the brackets first. 0 take away 2 is negative 2. And then 4 times the negative 2 equals negative 8. Yeah, we got it right for sure. Okay, next. Get rid of our brackets. Feed the chickens. So, negative 5 times 4, that's only one negative, so it's negative, and 5 times 4 is 20. Don't put a sign down because we're going negative times negative, right? There's an invisible 1 there, so it's a negative times a negative, which is a positive, and 5 times 1 is 5, and keep that x right there, equals 10. Now, we want to get this x by itself, looking for a step over here that'll get rid of one of these numbers by adding or subtracting. It's the negative 20. We're going to get rid of that by adding 20. Now, don't do this. Don't put positive 20 there, because if you did that, you just added two 20s to the left-hand side and nothing to the right-hand side. It's not balanced anymore. You need to add one 20 to this side and the other 20 to the other side over here. All right, that cancels out. You're left with 5x. 10 plus 20 is 30. And we have one more step. We've got to get the x by itself, and it's multiplying by 5, so we'll do the opposite. We'll divide by 5. Get x on this side. 30 divided by 5 is 6. Good. Okay. 27 equals 3 times 3x plus 6. The variable's on the right-hand side. It doesn't matter. We follow the same steps. So we're going to get rid of the brackets by expanding, by doing feed the chickens. So 27 is still here. 3 times 3x. 3 times 3 is 9, and we still have an x. 3 times 6 is 18, so plus 18. Got to get this x by itself. We need to add or subtract first, so I'm going to subtract. I'll subtract 18 from both sides. Ooh, it's not the easiest. Pull the calculator if you want. You get 9. So 9 equals 9x. Last step, this is 9 times x. Do the opposite. Divide by 9 on both sides. So those cancel. You get x, and 9 divided by 9 is 1. Not 0, it's 1. I'm not sure. I want to check this one. Okay, 3 times 1 is 3, plus 6 is 9. 3 times 9 is 27. Got it. Whoa, look at all the negatives in this one. So let's be careful here. We have to multiply negative 4 times negative 2 and negative 4 times negative 2x. Negative 4 times negative 2, that's 2 negatives, so it's going to be positive, and 4 times 2 is 8. Don't put down the sign, because now we're going negative 4 times negative 2x. Negative 4 times negative 2, 2 negatives again, it's going to be positive, and 4 times 2 is 8. And slap down that x again. And equals negative 8. Whoa, look at all the 8's here. What are we trying to do? We're trying to get this x all by itself, right? So we need to get rid of this 8 and this 8. Which one requires adding or subtracting? The first one. That's a positive 8, so we will subtract 8 from both sides. 8x equals. Don't put 0 there. That's not what it equals. This is negative 8, take away 8, but I like to add the opposite. You have 8 negatives and 8 more negatives. You have even more negatives now. You have 16 negatives. Last step, divide by 8. Since this is multiplying by 8, you got to get rid of it by doing the opposite operation, divide by 8. X equals. Negative divided by positive is a negative. 16 divided by 8 is 2. And we're done. Alright, one word problem. Samantha realized that if she subtracted 4 from her age and then multiplied the result by 4, she'd end up with her dad's age. If her dad is 48, hey, that's me. I'm 48. Is Samantha my child? No. Then how old is Samantha? So what are we trying to find in this question? We're trying to find Samantha's age. Sam, I'm going to call her Sam. Sam's age. Well, we don't know her age. So what do you want to call it? Let's call it M, or N, or X, or Y, whatever. So let's see, what are we doing? If we subtract 4 from her age, so subtract 4 from her age, what would that look like if her age is M and we want to subtract 4 from it? That would be M take away 4. And then what we want to do is multiply the result, like multiply all of this by 4. So don't just do this, don't just go 4 like that, or 4 times or something like that. No, we want to multiply this whole amount by 4. How are we going to show that? Not surprisingly, considering what we're doing today, we're going to put the whole thing in brackets. So when I do this, this means 4 times all of that. And if we do that, take away 4, then multiply by 4, you'd end up with her dad's age, and her dad is 48. So this amount here must be equal to 48. Now we can figure out Sam's age. How do we do that? Distributive property. Feed the chickens. 4 times m, 4m. 4 times negative 4, negative 16, and it still equals 48. So we got to get that m by itself. Let's get rid of the negative 16 or the minus 16 by adding 16 to both sides. So 4m, the 16s are gone. 48 plus 16 is 64. Last step, since this is 4 times m, we're going to do the opposite and divide by 4 on both sides. So m equals 4 goes into 64, break out the calculators, 16. How old is Sam? Well, her age is m, and we just found out that m equals 16. Sam is 16. Okay, hey, you know what else is interesting about her age and her dad's age? 16 and 48. Her dad is exactly 3 times as old as Samantha is. 16 times 3 is 48. I love it. That's awesome. All right, that's as hard as our equations are getting this year, so if you understand that, good for you. And if not, let me know so I can help you out. Bye.